Hello students, welcome to Diksha Karnataka YouTube channel. Abhyas KCET 2024 mock test 6 has been released. In this video, I'm going to discuss the solution of mock test 6. Uh, the physics part 1, question number 121 to 150. So if you haven't downloaded the question paper, please download the question paper through WhatsApp channel. Join the WhatsApp channel using the link which is given in the description box. Okay, yeah, let us start. Question number 121. If C be the capacitance and V be the electric potential, then the dimension formula of CV square is. Okay, you know energy stored in the capacitor, right? That is half C into V square, right? Here we need to find, or we need to tick the correct option or the correct dimension formula, which is the dimension formula of the energy. Okay, so what is the dimension formula of the energy? The dimension formula of the energy is ml square t to the power minus 2. Okay, so in the option A is also given, so a to the power 0. A is the dimension formula of the current. So this is the dimension formula of CV square. So the correct option is A. Okay, yeah. Next question. Question number 122. The velocity time graph of particle comes out to be non-linear curve. The motion is, here this is velocity versus time graph. Here the graph is non-linear curve. Okay, if the graph is non-linear curve in the velocity versus time graph, okay, then the acceleration is slope of the v versus t curve, right? Isn't it? V versus t graph. So the acceleration is non-uniform. Okay, acceleration is non-uniform. So option A says uniform velocity motion, wrong. Option B says uniform accelerated motion, wrong. If the motion is uniformly accelerated, then v versus t graph is linear. Okay, so option B is wrong. Option C, non-uniform accelerated motion, correct. Option C is the correct answer, right? Okay, next question. Question number 123. If range square is 48 times maximum height square, then the angle of projection is. Okay, so we know the formula of range, right? Isn't it? So the formula of range is u square sine 2 theta divided by g, right? So this is the formula of the range, right? And what is the formula for maximum height? The formula for maximum height is u square sine square theta divided by 2g, right? So in the question they have given range square is equal to 48 times maximum height square, right? So range squared, that is u square sine 2 theta divided by g is equal to 48 times maximum height squared. Maximum height squared, here u square sine square theta divided by 2g, here squared. Okay, u square sine square theta u square sine square theta divided by 2g squared into 48. Okay, so now take square root on both sides. Here u square sine 2 theta divided by g is equal to, what is the root of 48? Root of 48 is, here I can write 48 as 12 into 3, right? Isn't it? Isn't it 12 into 3? Sorry, 16 into 3, right? 16 3s are 48, right? So 16 into 3, root of 16 into 3 is 4 into root 3, right? 4 into root 3 into u square sine square theta divided by 2g. Here u square by g will get cancelled, right? And then 2 2s are 4. So now this becomes sine 2 theta. I can write sine 2 theta as 2 sine theta cos theta, right? 2 sine theta cos theta. 2 sine theta cos theta is equal to 2 into root 3 times sine square theta. right? So 2 will get cancelled. Sin theta will get cancelled, right? So tan theta is equal to, here tan theta is equal to 1 divided by root 3, right? So theta equal to tan inverse of 1 divided by root 3. So what is the value of tan inverse of 1 by root 3? So it's 30 degree, right? So the value of theta, that is angle of projection, is equal to 30 degree. So the correct option is D. Okay, yeah. Next question, question number 124. A rocket of mass 120 kg is moving vertically up at 600 meter per second such that gas is escaping at the rate of 1 kg per second. That is dm by dt. Here this question is based on variable mass system. Okay, dm by dt is equal to 1 kg per second, right? 1 kg per second. So we need to find out the acceleration of the rocket. Okay, acceleration of the rocket. Acceleration of the rocket is equal to your upthrust force divided by mass m, right? Mass of the rocket m. So what is the value of upthrust force? Upthrust force F is equal to u into dm by dt, right? U into dm by dt. So what is the value of u? In this case, the value of u is 600 meter per second, right? Isn't it? 600 meter per second. So F is equal to 600 into dm by dt, that is 1, right? Now the acceleration A is equal to F is 600, right? 600 divided by m is 120. So 0 0 will get cancelled, 12 5s are 60. So A equal to 5 meter per second square. So the correct option is B. This is the acceleration of the rocket. Yeah, next question. Question number 125. A 2 kg mass lying on a table is displaced in the horizontal direction through 50 centimeter. The work done by the normal reaction will be. Okay, here work done is equal to F dot S, right? F is force vector, S is displacement vector. Okay, so in scalar form, work done is equal to Fs cos theta. Theta is angle between F and S. In this case, force is normal reaction, right? This is the block. This is normal reaction, right? And what is the direction of the displacement vector? This way, right? Isn't it? This way or this way? Anyway, the block is displaced, okay, or the block is moved towards right. Here, it is displaced through 50 centimeter, right? Isn't it? In horizontal direction through 50 centimeter. Now, what is the angle between force and displacement? Here, force and displacement, it is 90 degree, right? So, cos 90 degree is 0. Now, work done by normal reaction is equal to 0. Okay, so the correct option is B. Simple one, right? Direct one. Next question, 126. A light rod of length L has two masses m1 and m2 attached to its two ends. Okay, let us draw the diagram. Here, two masses m1 and m2, right? These two are attached by light rod of length L, right? The moment of inertia of the system about an axis perpendicular to the rod and passing through the center of mass of the rod. So let's say this is the center of mass of the rod. Here we need to find moment of inertia of the rod about this axis, the axis which is passing through the center of mass of the this rod, right, or this system, isn't it? Center of mass of the system, right? Okay, so here the distance between mass m1 and the axis of rotation is L1. Okay, the distance between mass m2 and the axis of rotation is L2. Okay, first let us find the center of mass, okay, then we can easily find the moment of inertia, right? If we find the center of mass, then we can easily find L1 and L2, right? Now the total moment of inertia I equal to moment of inertia of this one plus moment of inertia of this one, mass M2, moment of inertia of M1 and M2, right? Isn't it? About this axis. That's it. Okay, let us find center of mass. Here, center of mass of the system, right? Here R is equal to M1 into, let us take this as origin, okay? This, the position of the M1 as origin. So now M1 into 0 plus M2 into L, right? M2 into L divided by M1 plus M2, right? M1 plus M2. So now R is equal to M2 into L divided by M1 plus M2, right? R is equal to M2 into L divided by M1 plus M2. So here what is R? R is L1, right? So we took the position of the M1 as origin, right? So C is, that is the position of the center of mass is M2 into L divided by M1 plus M2, right? So the distance between center of mass and the mass M1 is L1, right? So R equal to L1, isn't it? Okay, so now we found L1. So we can easily find L2. So L2 is equal to L minus L1, right? So if you take L minus L1, I mean if you solve this, you will get M1 into L divided by M1 plus M2, right? Isn't it? So now we found L1 and L2, right? Now we can easily find moment of inertia. Now the total moment of inertia I equal to M1 into L1 square plus M2 into L2 squared, right? Now moment of inertia I is equal to M1 into L1 squared, that is M2 into L divided by M1 plus M2 whole square plus M2 into L2 squared. L2 squared is M1 into L divided by M1 plus M2 squared, right? Now the moment of inertia I is equal to, here take M1 M2 as common, okay? So M1 M2 into M1 plus M2 into L square divided by M1 plus M2 whole square. So now M1 plus M2 will get cancelled. Finally, the moment of inertia about the center of mass I equal to M1 M2 into L square divided by M1 plus M2. So now the correct option is A. Okay, correct option is A, this one. Yeah, next question. Question number 127. The stress strain graph of a material is shown in the figure. The region in which the material is elastic. Here in the stress strain graph, OA is linear, right? That is, stress is directly proportional to strain, right? Stress is directly proportional to strain. This is Hooke's law, right? Hooke's law. So this is the region in which material is elastic, okay? So option A is the correct answer. Memory based question, direct question, right? Yeah, next question, 128. Two solids, P and Q, float in water. It is observed that P floats with half of its volume immersed in Q, immersed, and Q floats 2/3 of its volume immersed. The ratio of densities of P and Q. Okay, let us draw the diagram. Okay. So here the first solid, okay, this is P. It is observed that P floats with half of its volume is immersed. Half of the volume is immersed, right? That is V by 2. Okay. In the second one, that is Q, Q also floats, right? But 2/3 of its volume immersed, right? 2/3 of its volume immersed, isn't it? 2/3 V. Now we need to find the densities of P and Q. Here, let's say rho P is the density of P and rho Q is the density of Q, material Q. Okay. So what is the condition for floating? The condition for floating is buoyant force equal to gravitational force, right? So what is the buoyant force? Here the buoyant force is volume of the material P immersed in the water, V/2, into density of the water, right, rho W, into G, right, which is equal to gravitational force on this P. That is mass of the P is volume of the P, right, Vp, or yeah, we can say Vp. Okay, Vp here, Vp is V, right, V into density of the material P into G, right, G will get cancelled, right, V will get cancelled, isn't it? So rho P, that is density of the material P, is equal to rho W divided by 2. Okay, yeah. Now this is for this situation first, right? Now the second situation, again apply floating condition. Here 2/3 V into rho W into G. This is buoyant force acting on material Q, right, which is equal to gravitational force on material Q, which is mass of the material Q. Mass of the material Q is volume of the material Q, V, into rho W into, sorry, rho P, okay, not rho P, rho Q into G, right? Here Vg will get cancelled. Now rho Q is equal to 2 rho W divided by 3. Now we need to find the ratio of densities of P and Q. Ratio of densities of P and Q, right? Which is equal to here rho W divided by 2 whole divided by 2 rho W divided by 3. Okay. So now rho P divided by rho Q is equal to 4 divided by, sorry, this will be 3 divided by 4, right? 3 divided by 4. 3 by 4. Okay, so this is the ratio of densities of P and Q. So the correct option is B. Okay, 3 by 4. Yeah, next question, question number 129. The quantities of heat required to raise the temperature of two copper spheres of radii R1 and R2, R1 equal to 1.5 times R2, through 1 Kelvin are in the ratio of, okay, here the quantity of heat required to rise the copper sphere, okay, first copper sphere, the here the radius of the copper sphere is R1, first copper sphere is R1, okay. So Q1 is equal to M into here C, that is specific heat of the copper, into delta T, the change in temperature. Delta T is equal to 1 Kelvin, right? M is mass of the sphere. Mass of the sphere is volume of the sphere into density of the sphere. So now Q1 is equal to volume of the copper sphere 4/3 pi R1 cube into density of the copper sphere into specific heat of copper sphere into delta T. Delta T equal to 1, right? Delta T is equal to 1 Kelvin. Okay. Similarly, I can write Q2 as here. Okay, this is M1. Okay, Q2 as M2 into SCU, specific heat of copper sphere, into delta T. So Q2 is equal to M2. M2 is volume of the second copper sphere into density of the second copper sphere into SCU into delta T. Delta T is 1 Kelvin, right? 1 Kelvin. Okay. So now I need to take the ratio of Q1 and Q2. So Q1 divided by Q2 is equal to, see here, rho Cu, HCu will get cancelled, right? Isn't it? And 4 by 3 pi, 4 by 3 pi will also get cancelled. So now this will be R1 divided by R2 cube, right? R1 divided by R2 cube. So now here Q1 divided by Q2 is equal to, R1 is equal to 1.5 times R2, right? So 1.5 times R2 divided by R2 squared, right? So the ratio Q1 divided by Q2 is equal to R2 will get cancelled, 1.5 is 3 by 2, right? So 3 by 2 cube, okay? So this is cube. 3 by 2 cube is 27 divided by 8, right? 27 divided by 8. This is the ratio. So the correct option is A. Okay. Next question. Question number 130. 1 mole of an ideal gas is taken from A to B, from B to C, and then back to A. The variation of its volume with temperature for that change is as shown. Its pressure at A is P naught, volume is V naught, then the internal energy. Okay, we need to find internal energy, at which point the internal energy is, at which point, what is the internal energy, okay, whether internal energy changes or not, okay. We need to identify the internal energy, that's it. Okay, option A says at A is more than at B. No, right? Why? Because internal energy depends on the temperature. Internal energy depends on the temperature, right? Isn't it? Here the temperature is changing. No, right? Isn't it? So internal energy at A is equal to internal energy at B, right? So option A is wrong. Option B, at C is less than B. At C the temperature is higher, right, compared to at B, isn't it? So at C the internal energy is higher compared to B, right? So UC is greater than UB. So this is the internal energy, okay? At UC, which is greater than UB, not less than at B, okay? So option B is also wrong. Option C, at B is more than at A. This is also wrong, right? Internal energy at A is equal to internal energy at B. Option D, at A and B are equal, correct. So option D is the correct answer, right? At A and B are equal internal energy. Yeah, next question, 131. The mean free path of the molecule of a gas radius r is inversely proportional to. Okay, so here we know the formula of mean free path of molecules of a gas, right? That is lambda is equal to 1 divided by root 2 times pi n d square, right? 1 divided by root 2 time 1 divided by root 2 pi n d square. N is number density, that is number of molecules per unit volume, right? So now the mean free path lambda is equal to 1 divided by root 2 pi n into d is diameter of the molecule, right? So in this case it's radius. Radius is 4r square. D square is 4 times r square, right? So mean free path is inversely proportional to r square, right? So the correct option is B. Mean free path is inversely proportional to r square. Next question, 132. A 10 kg metal block is attached to a spring of spring constant 1000 Newton per meter. A block is displaced from equilibrium position by 10 centimeter and released. The maximum acceleration of the block. So here you don't need to draw the diagram and all, okay? So you know the formula of maximum acceleration of the block, right? Maximum acceleration. Maximum acceleration is equal to angular square of the angular velocity into amplitude a. Actually, it's omega square into x. X is a, right? In this case, x is a, isn't it? If you want to find the maximum acceleration, here x becomes a. A is amplitude, right? So a max is equal to omega square is k by m, right, into a. So now substitute the values, that's it. So now maximum acceleration is equal to k. K is 1000 Newton per meter divided by m. M is 10 kg into a. A is 10 centimeter, that is 0.1 meter, isn't it? 0.1 meter. 0.1 meter. So here 10 will get cancelled. 100 into 0.1 is 10. So A max is equal to 10 meter per second square. Okay, 10 meter per second square. So the correct option is B. Understood? Yeah. Next question, 133. Sound waves transfer. Option A says only energy, not momentum. No, it is wrong, right? Sound waves, that is mechanical wave, it transfers both energy and momentum. Okay, so the first option is wrong. It transfers energy. Energy is correct, but it also transfers momentum, right? So option B is wrong. Option C is also wrong. So the correct option is D, both energy and momentum. Okay, yeah. Next question, 134. A stone weight is 100 Newton on the surface of the earth. The ratio of its weight at a height of half the radius of the earth to depth of half the radius of the earth will be approximately. Okay, so we know the acceleration due to gravity varies when you move above the earth, okay, or when you move below the earth, or at depth d, right? So we know the formula of the acceleration due to gravity at height h above the surface of the earth, right? So g1 is equal to g divided by 1 plus h divided by r squared, right? So this is the formula for acceleration due to gravity above height h from the surface of the earth. So now g1 is equal to g divided by 1 plus h is r by 2, right? Half the radius of the earth, right? R divided by 2 divided by r squared, right? Then here g1 is equal to g divided by, here r will get cancelled. So 1 plus 1 by 2 is 3 by 2. 3 by 2 squared is 9 by 4. Okay, 1 by 9 by 4 is 4 by 9. So 4g divided by 9. Okay, 4g by 9. This is the acceleration due to gravity above the surface of the earth, right? Okay. So now g2 is the acceleration due to gravity below the surface of the earth. Okay, acceleration due to gravity changes as you move into the earth, right, or below the surface of the earth. So g2 is equal to, the formula is g into 1 minus d divided by r. What is d? D is depth, right? So now g2 is equal to g into 1 minus d is, in this case, what is the value of d? D is r by 2. So r by 2 by r. So r will get cancelled. 1 by 2 minus 1 minus 1 by 2 is 1 by 2. So now g2 is equal to g divided by 2. Okay, g2 is equal to g by 2. So what we need to find? Here we need to find the ratio, right? Isn't it? So g2 divided by g1, right? Isn't it? Sorry, here g1 divided by g2, right? g1 divided by g2. g1 divided by g2 is equal to here 4 divided by 9g divided by g divided by 2, right? G will get cancelled. Here g1 divided by g2 is equal to 8 divided by 9, right? So what is the value of 8 by 9, which is equal to 0.9, right? 0.9. So the correct option is D. Okay. Next question, 135. Water rises in plant fibers due to, this is the 10th level question, right? Everybody knows the water rises in plant fibers due to capillarity. So option A is the correct answer. That's it. Okay. Question number 136. If a charge on the body is 1 nanocoulomb, then how many electrons are removed from the body? Apply quantization of charge. Now the quantization of charge says the total charge is equal to integral multiple of E, right? E is 1.6 into 10 to the power 1.6 into 10 to the power minus 19 coulomb, right? So we need to find the number of electrons removed from the body, right? So now number of electrons removed from the body is equal to total charge of the electron, okay, divided by electrons, okay, total charge of the electrons divided by E. So now N is equal to, what is the total charge of the electrons? 1 nanocoulomb, right? Isn't it? So if you remove 1 nanocoulomb, if you remove electrons from the body, what happens? The body will get positively charged, right? Isn't it? So here the total charge of the electrons, removed electrons, is 1 nanocoulomb. So 1 into 10 to the power minus 9 coulomb divided by minus 9, this one is minus 9, isn't it? Divided by E is 1.6 into 10 to the power minus 19. So now solve this, you will get N equal to 6.25 into 10 to the power 9, okay, 10 to the power 9. 6.25 into 10 to the power 9 electrons removed from the body. That's why the body charged by 1 nanocoulomb, okay, or the body gets charged by 1 nanocoulomb, okay. So option D is the correct answer. 137. The potential of the electric field produced by a point charge at any point x, y, z is given by 3x square plus 5, where x, y, z are in meters and V is in volts, the intensity of the electric field. Okay, so we know the relationship between intensity of the electric field and the potential, right? So what is the relationship? Here intensity of the electric field is equal to gradient of the potential, negative gradient of the potential, that is minus dV divided by dr, right? So E is equal to minus dV by dr is dx, right? Isn't it? Dx I cap plus dy j cap plus dz k cap, right? Is there any y and z term? No, right? Isn't it? So now the intensity of the electric field along x-axis Ex equal to minus dV by dx. That's it. Now differentiate given function in terms given function with respect to x, right? So Ex equal to minus of d by dx of 3x square plus 5. So what is the differentiation of 3x square? Differentiation of 3x square is 6x. What is the differentiation of 5? 0. So Ex is equal to here minus 6x, right? So at what point we need to find the electric field intensity? At minus 2 comma 1 comma 0, right? Anyway, there is no y term and z term, okay, and x is equal to minus 2. Now substitute the value of x2 here. So now Ex is equal to minus 6 into minus 2. Minus 6 into minus 2 is plus 12. So Ex equal to 12 volt per meter. So the correct option is C, plus 12 volt per meter. Okay. Yeah. Next question. 138. A spherical conductor of radius 2 cm is uniformly charged with 3 nanocoulomb, right? So this is the spherical conductor. The radius of the spherical conductor is 2 centimeter and it is charged with 3 nanocoulomb. What is the electric field at a distance? 3 centimeter from the center of the sphere, right? Here 3 centimeter from the center of the sphere. We need to find electric field, right? So this point P is lying outside the sphere, right? Surface of the sphere, right? So what is the formula? Electric field will be equal to K into Q divided by R square, small r square, right? K into Q divided by small r square. Here R is greater than capital R. Capital R is the radius of the sphere, okay? So here E is equal to K is 9 into 10 to the power 9, right? Into Q. Q is 3 nanocoulomb. So 3 into 10 to the power minus 9 divided by 3 centimeter squared, right? That is 9 into 10 to the power minus 4. 3 centimeter is 3 into 10 to the power minus 2. 3 centimeter squared is 9 into 10 to the power minus 4 meter, okay? 3 into 10 to the power minus 2 meter. Here this is 9 into 10 to the power minus 4 meter squared. So now 9 will get cancelled, right? So E is equal to, here 10 to the power 9 by 10 to the power minus 4 is 10 to the power 13, right? So 10 to the power 13, okay, anyway 10 to the power 9, 10 to the power 9 will get cancelled. It will be 10 to the power 4 only, right? Isn't it? So 3 into 10 to the power 4. What is the SI unit of the electric field? It's volt per meter. Okay, volt per meter. So the correct option is A. Okay, direct question, right? Yeah. Question number 139. Pick out the statement which is incorrect. Option A, electric field lines forms closed loop. Wrong. It will never form closed loop, right? Isn't it? So option A is the correct answer, right? We have to pick out the incorrect option, right? Incorrect statement. Yeah. Option A is wrong. Option A is correct. The statement in the option A is wrong. Option B, electric field lines never intersect. This statement is correct, right? Isn't it? It will never intersect. Option C, the tangent drawn to a line of force represent the direction of the electric field. Again, this is also correct. These are the properties of the electric field lines, right? Isn't it? So option D says a negative test charge experience a force opposite to the direction of the field. This is also correct, right? So here we need to pick out the wrong statement, incorrect statement. So the correct option is A. Okay. Yeah. Question number 140. The equivalent capacitance between A and B as shown in the figure. Okay. Here we need to find equivalent capacitance between A and B. See here, 6 microfarad and 3 microfarad, these two are in series, right? And 2 microfarad, these two capacitors are in series, right? So then these two are in parallel, right? Isn't it? So let's say C1 is 6 microfarad, okay? C2 is 3 microfarad, C3 is 2 microfarad, C4 is 2 microfarad, okay? So now C1, C2 are in series, right? Isn't it? C1, C2 are in series. So C dash 1 divided by C dash is equal to here 1 divided by C dash is equal to 1 divided by C1 plus 1 divided by C2. Okay. So now C dash is equal to C1 C2 divided by C1 plus C2. Okay. Now similarly here for this, okay, for this series capacitors, 1 divided by C double dash is equal to 1 divided by C1 plus 1 divided by C2. Okay, sorry, 1 divided by C3 plus 1 divided by C4. Okay. 1 divided by C double dash is equal to 1 divided by C3 plus 1 divided by C4. Now C double dash is equal to C3 into C4 divided by C3 plus C4, right? So now C dash and C double dash, these two are in parallel, right? So equivalent capacitance between A and B, C equal to C dash plus C double dash. So C equal to C dash is C1 C2 divided by C1 plus C2 plus C double dash is C3 C4 divided by C3 plus C4. Okay, C equal to C1 into C2, C1 into C2 is 6 microfarad into 3 microfarad, right? So 6 into 3 into micro is 10 to the power minus 12 whole divided by C1 plus C2. C1 plus C2 is 9 microfarad, that is 9 into 10 to the power minus 6 plus C3 into C4. C3 into C4 is 4 into 10 to the power minus 12 whole divided by C3 plus C4. C3 plus C4 is 4 into 10 to the power minus 6, right? So now equivalent capacitance between A and B is here 6 3s are 18, right? So 9 2s are 18, isn't it? Now 4 will get cancelled. So 10 to the power minus 12 by 10 to the power minus 6 is 10 to the power minus 6, right? Here also 10 to the power minus 6. Now 2 into 10 to the power minus 6 plus 1 into 10 to the power minus 6. So C equal to 2 plus 1 3. So 3 into 10 to the power minus 6 farad, okay, or 3 microfarad. This is the equivalent capacitance between A and B. So option C is the correct answer. Okay. Yeah. Next question. Question number 141. Okay. So here if EAX, okay, EAX vector and EEQ vector, okay, EEQ vector represents electric field at a point on the axial and equatorial line of a dipole of dipole length 2a. Okay, so here dipole length is 2a, right? This is negative charge and positive charge q. Dipole length is 2a. Okay, here the point P, which is lying on the axial line of this dipole, right? At this point, the electric field vector is, in this case here, 2 kp cos theta divided by r cube, right? Or 2 kp by r cube. Okay, 2 kp by r cube, not 2 kp cos theta, 2 kp by r cube. Okay, now this is the equatorial point, right? That is the point lying on the equatorial line of this dipole, right? So here the electric field at this point is E vector is equal to, this is EEQ, right? This is EAX, which is equal to minus Kp divided by r cube, where K is 1 by 4 pi epsilon naught. Okay, K is 1 by 4 pi epsilon naught, right? So now we need to find the relationship between EAX and EEQ, right? So Kp by r cube is minus Kp by r cube is EEQ, right? That is electric field at the equatorial line, right? Isn't it? The point which is lying on the equatorial line. So now EAX vector is equal to, compare these two equations, which is equal to minus 2 times EEQ. Okay, so this is the relationship between EAX and EEQ. So the correct option is C. Okay, I hope everybody understood. So this one is very simple. Okay, yeah. Question number 142. An electric dipole consists of two opposite charges, each of magnitude 1 microcoulomb. Here minus q charge and plus q charge. Okay, it has minus 1 microcoulomb charge and 1 microcoulomb charge, separated by distance 2 centimeter. Okay, 2 centimeter. The dipole is placed in an external electric field of 10 to the power 3 Newton per coulomb. So this dipole is placed in an external electric field of 10 to the power 3 Newton per Coulomb. Okay. The maximum torque on the dipole. Okay. So we know the formula of torque on the dipole, right? Isn't it? So the torque on the dipole, tau is equal to P into E sin theta, P cross E, that is P cross E, which is equal to PE sin theta, right? Theta is angle between dipole moment and electric field vector, right? Okay. So here we need to find the maximum value of the torque, right? Maximum value of the torque on the dipole is equal to P into E. That's it. Why? Because to have the maximum value of the torque, sin theta has to be maximum, that is 1. So P into E, right? So tau equal to P, P is Q into D, right? Q into D into E. This is the maximum value of the torque. So now maximum value of the torque is equal to Q is 1 microcoulomb, that is 10 to the power minus 6, right? 10 to the power minus 6 coulomb into D. D is 2 centimeter, that is 2 into 10 to the power minus 2 into E. E is 10 to the power 3, 10 to the power 3 volt per meter. So now tau max is equal to 10 to the power minus 6 into 10 to the power minus 2 is 10 to the power minus 8. Okay. 10 to the power minus 8 into 10 to the power 3 is 10 to the power minus 5. So 2 into 10 to the power minus 5 Newton meter. So maximum value of the torque is equal to 0.2 into 10 to the power minus 4 Newton meter. So the correct option is A. Okay. Yeah. Next question. Question number 143. Two infinite parallel metal planes contain electric charges with charge densities plus sigma and minus sigma respectively. Okay, here two large metallic plates contains charge density sigma and minus sigma respectively, and they are separated by small distance in air. Okay, they are separated by small distance d in air. If the permittivity of the air is epsilon naught, then the magnitude of the field between the two planes with its direction will be. Okay, we need to find magnitude of the electric field between the two plates with its direction. So what is the direction of the electric field due to positively charged plate? So it is towards right. And what is the direction of the electric field due to negatively charged plate? Again, it is towards right, isn't it? Now, what is the magnitude of the electric field due to positively charged plate? So it is sigma divided by 2 epsilon naught. So what is the magnitude of the electric field due to this negatively charged plate? Again, it is also equal to sigma divided by 2 epsilon naught. So both are in the same direction, right? Now the net electric field is equal to sigma divided by 2 epsilon naught plus sigma divided by 2 epsilon naught. So net electric field is equal to sigma divided by epsilon naught, right? So what is the direction of this electric field? The net electric field, the direction of the net electric field towards negatively charged plate, right? Towards negatively charged plate, So option A says sigma divided by epsilon naught towards the positively charged plate. Wrong. Option B, sigma divided by epsilon naught towards negatively charged plane. Negatively charged plane, okay? Plate or plane. Negatively charged plane. So option B is the correct answer, right? Yeah. Next question. Question number 144. A 50 centimeter long wire and 1 millimeter square cross sectional area carries a current of 4 ampere when connected to a 2 volt battery. The resistivity of the wire is, okay, so here the wire connected to a 2 volt battery, right? The current in the wire is 4 ampere. Now we can easily find the resistance of the wire, right? So resistance of the wire is equal to V divided by I. Now substitute the values here. What is the value of V? V is 2 volt, right? What is the value of I? I is 4 ampere. So now R equal to 2 divided by 4. So R equal to 0.5 ohm. Okay, 0.5 ohm. Now we got the value of R. Now we can easily find the resistivity of the material. Length of the wire is given, area of cross section of the wire is given. So what is the relationship between resistivity, resistance, length of the wire and area of cross section of the wire? So R equal to rho into L divided by A, right? So rho equal to R into A divided by L. So now substitute the values. R is 0.5, A is 1 millimeter square, that is 10 to the power minus 6 meter squared, divided by L, that is 50 centimeter, 50 into 10 to the power minus 2. Okay, so if you solve this, you will get R equal to 10 to the power minus 6, sorry, rho, here this is rho, right, not R, this is rho. Okay, rho equal to 10 to the power minus 6 ohm meter. So the correct option is D, 1 into 10 to the power minus 6 ohm meter. Yeah. Next question. Question number 145. A metallic wire of cross-sectional area 4 millimeter square carries current of 3.2 ampere if 5 into 10 to the power 26 number of charge carries per unit volume flow across the wire. So this is the number density. Okay, number of charge carries per unit volume flow across the wire, then their drift velocity will be. Okay, we need to find drift velocity, right? So what is the relationship between drift velocity and current? Here drift velocity Vd is equal to current divided by N into E into A, right? I divided by N into E into A. So now Vd, that is drift velocity, is equal to I is current in the wire, that is 3.2 whole divided by N is 5 into 10 to the power 26 into here E is charge of the electron, 1.6 into 10 to the power minus 19 coulomb into A is 4 millimeter square, that is 4 into 10 to the power minus 6 meter squared. So now solve this, you will get Vd equal to 0.01 meter per second. Okay, so the correct option is C. I hope everybody understood. So this one is direct question, right? Yeah, question number 146. The variation between Vi is shown by the following 4 graphs. Which of the Vi graph for heating filament? Okay, so when you increase the current in the wire, what happens? There will be a more heat, right? More heat here, more heat or heat will increases, right? Heat will increases in the heating filament, right? In the heating filament, right? So there will be more heat in the heating filament, right? So if heat increases, that is temperature will also be increases, right? Isn't it? Due to which temperature increases. If temperature increases, what happens? The current will decreases, right? Isn't it? Current will decreases. If you draw V versus I graph, here I versus V graph, right? Isn't it? I versus V graph. I versus V graph. So first, current increases. As the voltage increases, current will also be increases, right? So due to the more heat, the temperature will also be increases. So as the value of temperature increases, the current will decreases, right? So then it will be constant like this. Okay, so the correct option is A. Okay, understood? Yeah, next question, 147. A metal wire is subjected to a constant potential difference. When the temperature of the metal wire increases, the drift velocity of the electron in it. Okay, so here when the temperature increases, okay, temperature increases, the thermal velocity of the electron increases, right? Thermal velocity of the electron increases, isn't it? So as the value of thermal velocity of the electron increases, the kinetic energy will also be increases, right? Isn't it? kinetic energy will also be increases. Due to the increase in kinetic energy, there will be more collision, right? More collision. Here more collision between the electrons, right? More collision between the electrons. Okay. As the here, as the number of collision increases, what happens? Number of collision increases, then the drift velocity decreases, right? As the number of collision increases, drift velocity will be decreases, right? Isn't it? So here the drift velocity of the electron in it increases. Wrong, it decreases, right? So option A is wrong, option B decreases, correct, and the thermal velocity of the electron increases, correct. So option B is the correct answer. Okay, yeah. Next question, question number 148. 3 electric bulbs with same voltage ratings of 100 volts, but wattage ratings of 40, 60 and 100 watts respectively are connected in series across volt supply line. If their brightnesses are B1, B2, B3 respectively, then okay, we need to find the order, increasing order or decreasing order of the brightness. Okay, yeah. So here power is equal to V square divided by R, right? Here the rated power P equal to V square divided by R. So R is equal to V square divided by P, the rated power, right? So V is constant, right? That is 100 volts. So now R1 is equal to V square divided by 40, right? R2 is equal to V square divided by 60, right? R3 is equal to V square divided by, here V square divided by 100, right? Here we got the value of R1, R2, R3, right? So from this I can write R1 is greater than R2 is greater than R3, right? So resistance in the first bulb is greater than resistance in the second bulb is greater than resistance in the third bulb. Okay, yeah. So we know that heat produced H is equal to I square into R, right? All 3 bulbs are connected in series, so there will be no change in the current, right? Isn't it? The current flowing through each bulb is same, right? Isn't it? So R is changing, right? R1 is greater than R2 is greater than R3. So therefore H1 is greater than H2 is greater than H3, right? So from this I can conclude that brightness in the first bulb is greater than brightness in the second bulb, which is greater than brightness in the third bulb, right? So the first option is the correct option, right? B1 is greater than B2 is greater than B3. Yeah. Next question, 149. Figure shows network of currents. The magnitude of currents is shown here. The current I will be. Okay, so this is the network of the current shown. Okay, we need to find the current I, right? That is this way. Here we need to find the value of current. Okay, so here we need to use Kirchhoff current law, right? KCL rule, right? So what is the statement of KCL? What is the statement of the KCL? The algebraic sum of current entering, right? The algebraic sum of current entering to a junction, okay, is equal to algebraic sum of current exiting from that junction, right? At that junction the net current is equal to 0, right? Here this is I, okay, I3 and I4, right? This is the Kirchhoff current law, right? Isn't it? Okay, so here the current entering, right? Isn't it? The total current entering. Here the total current entering to this circuit is 12 ampere, 5 ampere and 3 ampere, right? So 12, ampere plus 5 ampere plus 3 ampere, right? So this is current entering. So I entering is equal to 12 plus 3, 5, sorry, 15, 15 plus 5, 20. So 20 ampere. So which is equal to current exiting, right? Current exiting, isn't it? So which is also equal to 20 ampere. So the correct option is D. Okay. Yeah, the simple one, direct one, right? Yeah, the last question, question number 150. A charged particle is moving along a magnetic field line. The magnetic force on the particle is. So this is the direction of the magnetic field line. Okay, the charged particle is moving along the direction of the magnetic field line. So what is the force on the particle, right? The force on the particle due to magnetic field F equal to Q into V cross B, right? Q into V cross B. So in magnitude F equal to QVB sin theta. QVB sin theta. Theta is angle between V and B. Okay, theta is angle between V and B. So what is the direction of the V and B? Both are in the same direction, right? So the angle between V and B is 180 degree. So sin 180 degrees 0. So force acting on the charged particle is 0. So option D is the correct answer. Okay. Yeah, I hope everybody understood how to approach the problem and how to solve the problem. Okay. Thank you. Thank you so much. If you love this video, please like and share. If you want to watch more such videos, please subscribe.